Welcome you all to dieselship.com. This series of educational videos is presented to you by Sriram. And this video is especially produced by Dieselship Academy. So in this video, we're going to see about the purifiers, or commonly called as the centrifugal separators. In detail, we're going to discuss about the vertical and horizontal shaft arrangement, the friction clutch and the position of the brake pads, and the desludge mechanism. Let's discuss about that. Let's start with the vertical and horizontal shaft arrangement. The picture shows the general arrangement of a centrifugal separator. It might be a purifier or a clarifier. Here we have the vertical shaft upon which the bowl is mounted, and we can find two bearings which support the entire vertical shaft. The top bearing is of special type, which is having 6 buffer springs mounted radially so that it can completely absorb the vibration of the vertical shaft. The bottom bearing is a simple ball bearing which can withstand the vertical shaft's thrust. And in between the two bearings we have a worm gear, which is very much useful in conversion of the horizontal motion to the vertical motion. In fact, it is rotary motion. Now let's move on to the horizontal shaft. The horizontal shaft on either end is supported by simple ball bearings to just withstand the weight of the horizontal shaft and allow it to rotate. One end of the horizontal shaft has the electric motor, usually the prime mover of it, and the other end may have an attached positive displacement pump, or it may be free. It depends on the manufacturer and the shipboard system requirement. The special feature about the horizontal shaft is it also has the friction clutch or the brake drum. It serves for two purposes. The friction clutch, it can accommodate the centrifugal clutch pads inside of it and also acts as the brake on the outside. So it serves for two purposes. The worm wheel on the horizontal shaft is useful, and it's meshed with the worm gear on the vertical shaft just to convert the horizontal rotary motion into vertical rotary motion. This worm wheel on the horizontal shaft is attached with a split pin or a taper pin on the horizontal shaft, so that any obstruction on the drive mechanism, the pin will shear off, preventing the gears. Let's now discuss about the desludge mechanism in detail. Different modes of desludging will differ depending upon the manufacturer. This is a very basic type where we can understand the desludging cycle, how it happens basically. So in order to do that, let's understand what are the components present at the basic purifier. We have the vertical shaft, and the dirty oil is entering the purifier through the center and distributed throughout the bowl chamber due to the centrifugal force. It climbs up the disc stack where the dirty particles get accumulated as sludge at this place, and the clean oil is entering and it is being pumped out through this channel, and the water which is getting accumulated is passing over here in this channel, and through the dam ring it gets out. And I call the water pressure, or the water which maintains the bowl closed, as operating water, or the water which ensures the purifier is in operation is operating water. This channel is called as operating water channel, and the nearby one is called the desludging water channel. Now the operating water is keeping the bowl closed due to its pressure, and the sludge is not being discharged out. Let's see how a desludging cycle works. The desludged water enters, it opens the plug valve over here, thus the operating water is drained from this, where the ball opens with a jerk or a bang sound, and the sludge, due to the high centrifugal force, is being discharged out. Let's see once again what happens. The operating water through the channel F is keeping the ball closed, and the sludge is getting accumulated here. The channel B is operating water channel, and channel D is the desludge water channel. When I desludge it, through the channel D, the desludge water enters and opens this valve, and thus the operating water is drained from here, ensuring the bowl is getting opened and the sludge is thrown apart. So this is how the desludging happens in a purifier. Alright, the next will be the centrifugal clutch and its arrangement. Let's now discuss about the friction drum. The picture here shows the inside view of the friction drum. Here we have the central hole through which the horizontal shaft passes through, and we have 3 fulcrum pins upon which the clutch pads are mounted. The number of pads depend on the manufacturer and the speed of the horizontal shaft. It may vary from 2 pads to 8. Also, we have the rest pins over here upon which the pads rest when the purifier is stopped. Each pad has a rubber lining on its shoe, which is commonly called as Ferrado lining, and Ferrado being a famous company which manufactures the rubber lining. Let's now see the direction of rotation and the axis of the clutch pads. On seeing this picture here, we come to know the direction of rotation is anti-clockwise, and it's also given by the arrow mark. And I put a red line or mark over here just exactly at the fulcrum pin of the clutch pads. Now, with respect to the axis, the clutch pads here trail behind. Do you think this arrangement would be right on the purifier? Well, with last picture, anti-clockwise being the direction of rotation, we had the clutch pads trailing behind the red mark, but now the clutch pads are forward of the red mark. So which one do you think is right? So both the pictures in front of you now, one with the axis at the center and the pads trailing after the axis, and the other one, the axis here and the shoe pads being forward of the axis. So which one do you think is right? The picture on the left side or on the right side? The picture on the left side, that is the picture shown on the screen now, is the correct arrangement. Most of them are not aware, and we always think that the shoe pads trail the axis with anti-clockwise being the direction of rotation. No, it isn't. It's always forward so that the purifier horizontal shaft can be brought to the rated speed with friction, with the help of friction. Alright, we will move on to the brake drum now. Let's now see about the braking arrangement on the horizontal shaft. We have the horizontal shaft here, and this is the friction drum with which we had the clutch pads inside, and the outside of the drum is where we have the brake lining or the Ferrado lining. When we put on the brakes, when we lift the lever up, there is a cam which is eccentric which pushes this lining, and it creates a friction on the friction drum and applies a brake on the horizontal shaft. It is sometimes recommended to stop the purifier always by applying a brake. When we apply the brake and stop the purifier every time, the purifier deceleration passing through the critical RPM is suppressed, or the purifier, when applied a brake, comes to stop much faster than it's allowed naturally to come to stop. That is the reason it is always recommended to stop the purifier by applying the brakes. But individual engineers have to experience whether do we have creating any damage to the bearings or not. It always depends on individual's experience. Hope you guys have enjoyed this video. For more videos, log on to dieselship.com.